What's differentiation? Differentiation is a method of finding the derivative of function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. When do we apply? We can use differentiation determine if a function is increasing or decreasing. A function is increasing if its derivative is always positive. A function decreasing if its derivative is always negative. What are other applications of differentiation? They are related rate, analysis of function, apply maximums and minimum values, and Rolle theorem, mean value theorem, which is MVT. Okay. Next, what is apply maximum and minimum problem? Application of maximum and minimum problem is the process of finding maximum or minimum value is called optimization. For the example, maximize the profit in the company or minimize the cost, or find the least amount of material to make a particular object. Next, how to solve applied maximum and minimum problems. First, you need to find the derivative. Second, let the derivative equal to 0 and find the values and the variables. Third, second derivative test. If second derivative test is more than 0, it is minimum value. And if the second derivative is less than 0, it was a maximum value. Next, problem statement and solution. A tupperware has a rectangular base of length 32 cm, width 8 cm, and height y cm. If the volumes of the tupperware is 108 cm, A. Show the surface area ACM is A is equal to AX squared plus 396 per x. 108 is equal to AX squared y. Y is equal to 108 per 9x squared. Let alone y is equal to 336 per x squared. Now simplify the equations that were given is A is equal to 9x squared plus 2xy plus 9xy. And we got is 9x squared plus 11xy. Now we sub y equal to 36 per x squared into 1. And the result is 9x squared plus 11x times with 36 per x squared. Now we simplify the equations and we got is 9x squared plus 396 per x that is shown is equal to the equations that were given at the questions A. Now the question B asked is to determine the value x for the which surface area of the power is minimum. Hence, find the minimum surface area of the power. Now we're using the area equations that given in questions A, which is A is equal to 9x squared plus 396 per x. Then we differentiate the equations. dA per dx is equal to 18x per 80x. Substitute with 396 x minus square. And the answer is 90x minus 396 per x squared. Then we find the value of x. 18x is equal to 396 per x squared. 18x x 18x cubed is equal to 396 x cubed is equal to 396 per 18. And we simplify the x, and the x is equal to 2.8. Then we substitute the x into the equations that were given in A, which is A is equal to 9x squared plus 396 per x. And 9 9 times with 2.8 plus 396 per 2.8. And the answer is 211.99 cm cubed.
And then
Then we got the equations that we solved the previous one is 18x minus with 390x squared. My, we differentiate the equations and we got is 18 plus 792x negative cube. We differentiate again the ADX is equal to 18 plus 792 per x cube. When x is equal to 2.8, then we substitute x is equal to 2.8 into the equation. Is equal to 18 plus 792 per 2.8 cube, and the answer we got is 54, which is the minimum surface area of the Tupperware.
next, application of maximum and minimum. Application of maximum and minimums refers to such application exist in economic, in business, and engineering. Many can be solved using this method of differential calculus described above. For example, in any manufacturing business, it is usually possible to express profit as a function of the number of units sold.
For conclusion, application of differentiation is used to compute the rate of change. We can accurately count the difference in change happen. We can use these ways to answer another problem that related in our day life.